In this section, we'll introduce calculation optimization techniques, including tips for improving performance of aggregations, table calculations, conditional functions, and more. Goals for this section include reviewing common calculation types, including row-level functions, aggregators, table calcs, and LOD expressions. In addition, we'll explore performance optimization tips for aggregation and table calculations. We'll optimize syntax for conditional or logical calculations to maximize efficiency, and we'll leverage calculated groups or sets for live connections. Up next, we'll be diving into the differences between calculation types and the performance factors related. Calculations can be applied at various levels in Tableau, and each calculation type varies in terms of workbook functionality and performance. First, let's look at row-level calculations. These calculations occur at the lowest level in the data source and are typically string or mathematical calculations. One of the big opportunities for calculation optimization fall in this area. Because these calculations are calculated across individual rows, they can effectively be pushed back to the database for processing, which will free up Tableau's processing load. Next are aggregate calculations. These calculations roll up to the level of detail of the view created using aggregate functions such as sum, average, and more. Next are table calculations. These calculations materialize after a view has already been rendered, making them one of the harder calculation types to optimize. We'll talk more about options for optimization of table calculations in the upcoming lessons. Some examples of table calculations include rank, difference, running total, and more. And finally, level of detail calculations. These are specialized calculations which control the level of detail applied within the calculation. These calculations can effectively ignore or include extra level of detail from what's inside the view. Normally, Tableau's calculations will be subject to the view at hand, but level of detail calculations help you control this. While powerful, LODs can become problematic if not used correctly. Up next, we'll dive a bit deeper into aggregate calculations. Aggregation can be defined within calculations, or applied to your outside fields. There are two main types of aggregation: undefined aggregation and defined aggregation. Let's take a look at undefined aggregation first. Here, logical calculations which don't define the aggregation type used will force Tableau to do logical checks at each row level in your calculation. This can greatly impact the performance of a logical calculation which leverages measures. You can see in the example in our view that we haven't wrapped an aggregation around our metrics, so sales, quantity, and discount are referencing the row-level records. Alternatively, defined aggregation places the aggregation inside your calculation. Since we've called out our aggregation, that will happen first in the order of operations inside Tableau, and then the logical checks will be performed. Since the measures are aggregated first, the logical checks are much simpler. They're limited to only those lines you've called out in the calculation instead of thousands of individual calculations at row level. For example, if your view is rolled up to country level, but you have order line detail, the undefined aggregation would do the logical checks at row level, order line, but the defined aggregation that you've set inside the calculation would aggregate up to the country level first and then do the logical checks. A quick pro tip: when aggregation is not defined in the calculation, only a single aggregation type can be defined for a field at one time. When you pre-aggregate inside a calculation in defined aggregation, you can have multiple types of aggregation for measures called out inside that calc. In our example on the right, you can see that we're using sum for some of our calculation, but we're also using other aggregation types like average. Also note that regular aggregation functions like min and max are more efficient than average and attribute because they pick one value rather than reviewing all values. Now that we've talked a bit more through aggregations, let's jump into our own workbook and review some of these in our own calculations. Okay, so we're back in our Tableau Desktop Performance Filter Optimization workbook. Since we've moved on to the next section, which is Calculation Optimization, we're going to go ahead and do a File Save As to create a new workbook. This will help us keep track of our changes as we go through the course. So let's go ahead and change this rather than Filter Optimization to Calculation Optimization. Go ahead and hit save. And now we've got a fresh workbook to start with. Now let's go ahead and find our map tab. Select that and let it render. Now we can see inside our data tab, we have a multi-measure already created. If we go in and edit that, we can see that we have a multitude of measures inside our calculation using a logical case function. This will allow us to switch out different measures in our view, but what we don't have is an aggregation listed. That means that this calculation's logical check is going to happen at row level rather than the level of the view. We're going to want to go ahead and define those aggregations up front so that this will run a little bit more efficiently. Let's go ahead and wrap each in a sum so that we have that defined aggregation. Note that if you do this to one of your fields, you're going to have to do it to all of them. As our rule of aggregations applies, we need to have equal types of aggregation inside our calculations. So we can't have an aggregate and a disaggregate in the same view, and you'll get errors if you do that. If you do it to all of your fields, then you'll see that the calculation is valid. Now when we hit OK on this, it's going to temporarily disrupt our field, which is located in some of our sheets. That's because we're changing our aggregation from outside the field to inside. Normally, a field will automatically aggregate as sum inside the view, but since we're aggregating inside our calculation, it will now be listed as AGG when we bring it into the view, but it'll temporarily become a red pill because we need to redrag our field over that pill to replace it. So let's go ahead and hit OK. Okay, we'll scroll down and we can see that we do have a red pill, but that just means that our aggregation is now changed, so we can go ahead and just drag this field back out and we'll be all set. So let's scroll down, we'll grab multi-measure again, drag it right over the red pill, and we'll let go, and you'll see how it changes from sum to an AGG, which is a defined aggregation inside of our calculation. All right, perfect. Let's go back to our dashboard and see if we have any other issues with our multi-measure. Okay, right away we can tell that there's no errors on the other sheets. The reason we can tell that, we won't be able to see if there's a red exclamation point or a red pill visible in our view, but if you saw any of our sheets become opaque, that means that there's an error on the sheet. So you can go in, find the pill, replace it, and you'll be all set. But we're good to go for now. So we'll go ahead and we'll go back to start here. We'll save our workbook. And now that we've talked through aggregation and its performance impact, let's take a look at level of detail calculations and their performance impacts. Level of detail expressions allow users to control the granularity at which calculations are performed and can be used as alternatives to other calculation types. When considering using level of detail calculations, it's important to think of the data included in the view which you've built and the grain of the data source being used. The first question to ask is, does my question require ranking, recursion, moving calculations, or inter-row calculations to answer it? These are essentially calculation types which require a visible table to apply a calculation, which would leverage table calculations to do. So if your answer is yes, use table calculations. If the answer is no, consider next if you have all the data needed in the view to conduct your calculations. If the answer is yes, you could leverage table calculations to conduct your calcs. The final question you should ask is, does the granularity of the question match the granularity of the view? If the answer is yes to this question, a basic mathematical calculation could be used, but the ideal would be to push these simple mathematical or logical calculations back to the data source itself. If the answer is no, then you'll likely use level of detail calculations, which can control the grain regardless of the view presented. LOD calculations can also take the place of table and basic calculations when the need is there. Note that LODs will work better on well-designed data sources leveraging logical tables. The best course of action in evaluating calculations in terms of performance is to simply try each out and test the resulting performance of your calculations. In some cases, level of detail calculations will work better than table calculations, but that's not always the case. Much depends on the source that you're using, if it's a live or extract connection type, and the calculation logic you are trying to perform, in addition to the complexity of the view that you're bringing the calculation out to. During this section of the course, we'll give you some basic guidelines around which calculations perform better than others generally, but you should always test out all of your options before settling on one for your dashboard. Up next, we'll dive deeper into table calculations. Table calculations are performed at the view level after the query is processed, and can slow workbook performance when applied to large or extremely detailed views. Generally, the more detailed or complex the view, the harder table calculations need to work. Let's look at some alternatives to table calculations which can be leveraged if table calculations cannot be improved with the view in question. First, let's look at aggregating the data. Aggregating data to the level required for your calculations inside the data source can alleviate the need for table calculations. This can be accomplished by removing unnecessary columns, aggregating on visible dimensions, and extracting your data. This way, regular calculations can be leveraged at the default grain without doing any table calculation work. Additionally, you can also create a view or a table at the database level which mimics the level of detail needed for your calculations. This process is similar to the process you go through using extracts, but it's done at the database level rather than inside Tableau. Note that this solution may not work for all scenarios. Sometimes you'll want to keep the deeper grain in your data for other parts of your dashboard, and therefore you won't be able to do the aggregation work at the back end without risking losing the information in other areas for other end users and use cases. Another alternative is to use level of detail expressions. LODs help control the grain at which calculations are processed. In this way, regardless of how a view is constructed, they can choose which level a calculation is completed at. LODs are versatile, but always test the performance difference and analyze the trade-offs between LODs and table calculations before committing to one or the other. Remember that table calculations are by their nature relatively efficient. Always review the ways of reducing table calculation complexity before looking at alternatives. Generally, the way to do this is just to reduce the complexity of your view by removing dimensions and aggregating to higher levels. Now that we've talked high level about table calculation performance, let's go into our workbook and apply some of our alternatives. We're back in Tableau Desktop and we're looking at our Tableau Desktop Performance Calculation Optimization workbook. There are several table calculations in this workbook, and we'll be modifying, replacing, or removing things to make things more efficient for our workbook and a better fit for our end use case. First, we'll move over to the Maps tab, and we'll hover over our table calculation that we can see in our marks. You can tell that by the triangle which is next to our pill. The number of persons injured table calc is doing a running total by borough and location. You can tell that by right-clicking and choosing Edit Table Calculation, and it will show the definition of how our table calculation is operating. It looks like the person who created this workbook was trying to do a total by borough, which can be calculated much more efficiently using a level of detail calculation, especially in the view that we're looking at here. So let's start by creating an LOD to replace this calculation. Let's close our table calculation view. We'll right-click to create a new calculation. Choose Create Calculated Field. We'll delete the field that came in, and we'll start typing our calculation. Let's call this calculation Total Persons Injured by Borough. And our calculation is going to be a fixed LOD on borough, and we'll do a sum of number of persons injured. Let's go ahead and start typing fixed. We'll choose Enter. Then we'll type in borough. Enter again. Then we'll define our aggregation. So we'll do a sum of the number of persons injured. Close our brackets, squiggly bracket, and that's our calculation. Let's go ahead and hit OK, and we can see our calculation's been created. This will be a more efficient calc that won't look at the different marks in the view to do the calculation. Let's go ahead and drag this calculation right over the calculation that was inside our view, which used to be a table calc. Okay, that's much better. Now let's go to our Table Street Level Metrics tab and modify another field there. Looks like we've got two table calculations inside this view already working. If we right-click and edit our table calculation, we can see that these are just doing percent of total down our table, and we're going to be reformatting this view pretty significantly. So to make things more efficient before we do that, let's go ahead and just select our two table calculations inside this view with Control or Command, and we'll just drag them straight off of the view, because we won't be using them for the reformatted version of this table. No need to keep table calculations that we don't need, and this will help performance a bit. Now let's go back to start here. We'll save our workbook, And next we'll be looking at conditional calculations and their performance considerations in more depth. Conditional calculations are performed in the order you define them, and should be organized with the most common outcomes first to maximize efficiency. Tableau will process your calculation logic until a match is found, so putting the highest frequency matches first will allow Tableau to process the data quickly, but also eliminate those records for later pieces of the logic which will return less values. In the example shown, we can see that we are starting our conditional calculation with a null check. After reviewing the number of records for each dimension option, we can see the order of occurrence for each borough and have subsequently ordered our conditional statement in that same order. This will help optimize our query for the best performance possible. The easiest way to do your check is just bring out your dimension on a separate sheet, bring out either your number of records or your count of your table, and get a general idea of the frequency of each option. That way you can better structure your conditional calculation in the order of highest to lowest in terms of frequency. That way you'll pull out the biggest chunks of data first, apply the logic, and then you'll have less to work with later on in the conditional calculation. A quick pro tip around conditional calculations: using else if without a space is faster than using else if with a space. These are two distinct functions that you can utilize in Tableau, but the else if with a space will generate more complex logical tests because it's actually using two tests instead of one. Additionally, using an in function will perform faster than several or functions in your conditional calculations. These quick tips will help you out with your conditional calcs and making them quicker. Now that we've talked high level about conditional calculations, let's jump into our workbook and clean up a few of our own calculations. Alright, we're back in our Tableau Desktop Performance Calculation Optimization workbook. We're going to create a new cleaner borough field using logical function type calculations, and we'll be employing the order by occurrence methodology that we talked about in this lesson. Let's go ahead and start by creating a new sheet. We're going to name this sheet Borough Test. Let's start by just seeing how many records we have for each borough type. We'll double click on borough so we've got that listed out, and then we're going to find our Bike Maven data count field. Here's our count field here. We'll just double click and that will bring out our record count for each dimension. Let's go ahead and just use show me to make this a bar chart quickly, and then we'll go to our axis and we're just going to sort our data descending. So it looks like null is our highest record value, and then it goes down from there. Now let's make our calculated field using conditional logic. We'll right click on our borough field in our data pane, and we'll go down to create calculated field. We're just going to name this borough new, and we'll start by just deleting the field, and we'll start typing our conditional calc. So this is going to be if is null borough then other. So that's going to be our null check. You can see that's the first ranked in terms of order of occurrence. So we want to take care of that one first, and it'll cut out a bunch of data for the rest of our if statement. All right, so then we'll go with an else if without a space, because that's our quicker option. We'll say else if borough equals Brooklyn in all caps, because that's how the data is, or borough equals Manhattan, then Brooklyn and Manhattan. Else if, and you can see we're going down the list here, borough equals Queens, then Queens, and then else if borough equals Bronx, then Bronx, and then else Staten Island. And our if statement right there, and that's looking good. So you can see here, pretty straightforward. We're just going down in our order of occurrence. We're conditionally calculating in that order to optimize the query. We're using else if without the space because it's a bit faster. And we'll just go ahead and hit OK. All right, now to check that this worked, let's just go over to our map sheet. And right now we have borough on color, so we'll drag out our borough new, drop that in our view, and just see if that worked. Okay, perfect. That's working great. So now let's just go back to our Start Here tab. We'll save our workbook, and up next we'll be diving into calculated groups. When using live connections, define calculated groups using sets or case statements rather than native grouping tools. For extract connections or data sources which are structured well and use relationships, native Tableau grouping functionality is the best choice. Native grouping is optimized for these situations and should run faster than other alternative grouping choices. For live connections, we have a couple other options rather than native grouping that will give us better performance results. The first is case statements. Case statements provide a straightforward alternative to native grouping. These are familiar logical calculation functions which, if ordered appropriately, can perform better in some live connection scenarios. Second, leveraging sets are a good option if you are looking to make your groups conditional or use logic for special use cases. Sets are faster than most Tableau calculation functions and give you the flexibility to use these specialized groups in filters, calculations, and more. It should be noted that alternatives to any native Tableau functionality should be tested against each other in order to check their performance results. No two scenarios, data sources, workbooks, or use cases are created the same, and performance will differ. Let's take a quick look at some benefits of using sets. Sets are one of the first operations processed by Tableau, making them ideal for larger data set filters. Since the data will be filtered out very early in the order of operations using sets, it will allow other calculations and filters to process more quickly, enhancing the overall performance of the dashboard. As mentioned prior, sets happen earlier in the order of operations in Tableau, and as a result, this will help with performance. Additionally, the way sets create VizQL queries is tuned to be more performant overall. This will lead to sets being more speedy than almost any calculation or custom group, regardless of the source type. Another benefit unrelated to performance is that sets allow for additional conditional thresholds that are not found in native grouping functionality. This includes referencing measure values and embedding other conditional logic. You can also do this in calculated fields using logical functions, but sets will perform these actions earlier and generally quicker. Later on in this section of the course, we'll be leveraging sets in place of some other features, and those will help enhance our calculated groups as well. Note that sets are not applicable in all scenarios. They have limitations in terms of usability in some cases, such as filtering dropdowns, where traditional filters offer more options in terms of functionality. Though the advent of set control has helped level the playing field quite a bit between sets and filters. Up next, we'll be discussing other common pain points related to calculation optimization. Now let's look at a few common pain points related to calculation optimization. We'll first review the pain point, and then we'll take a look at different alternatives to try and resolve our issues. First, let's look at blended calculations. Blended calculations require multiple queries from at least 2 data sources to be completed. This can hamper performance and limit query optimization. A good alternative to blended calculations is to leverage Tableau's data modeling options. Tableau's logical relationships model offers the ability to join sources together situationally and optimizes queries effectively through the use of query fusion and parallel processing. Next, let's take a look at string manipulation. Parsing or modifying strings through functions like left, split, and regex can be resource intensive. Instead of using string manipulation in Tableau, a good alternative is to push these types of calculations back to the database. String manipulation is typically a row-level application and should easily be transferable back to the database as long as you have the business logic. Next are parameters in calculations. Parameters can't be materialized inside calculations, which makes Tableau calculate them each time a workbook is open. To help with this, you can split calculations up to separate parameters out. The calculations without the parameters can materialize, while the others will not. This will lighten the load on the calculations that don't have parameters in them, and is especially useful for long conditional calculations. Finally, are external services. External services are typically slower to respond and are dependent on off-platform technologies. One alternative is to use Tableau's built-in features. Many of the external platforms' modeling and mathematical features are now available in Tableau. If you can leverage the analytics pane, modeling calculations, level of details, and more, it's often more efficient than using external services. Now that we've talked about some common pain points, let's go into our workbook and apply some of these methodologies. Okay, we're back in our Tableau Desktop Performance Calculation Optimization workbook, and we're going to go over to the Maps tab. All right, now that we're on the Maps tab, let's go over to our drugs or alcohol calculation, right-click, and choose Edit. This calc is using regular expressions, which is probably a bit of overkill for what we're trying to do. Essentially, we're looking to isolate drug and alcohol-related accidents. We talked about sets in the last lesson, and you could see how the sets on their own are more performant. So by removing this string calculation and implementing sets, this will be a great 1-2 efficiency punch. Let's go ahead and find the contributing factor vehicle to field. We'll go over, we'll right-click, and choose Create Set. Now we'll go ahead and just select alcohol involvement and drugs illegal to isolate our drugs and alcohol factors, and we'll name this set Drugs and Alcohol. We'll click OK to close our set. You can see that's been added right here in our data pane. Then we'll go ahead and drag our drugs and alcohol set over to our filter shelf. We'll close out of our calculation. We'll right-click on our set. We're going to choose In and Out, so we can either include or exclude our drugs and alcohol factors. For now, we'll just choose both because we want them all to show. And then we'll go ahead and we're going to apply to all using this data source. All right, that's looking great. So we're not going to end up using our drugs and alcohol regular expressions. Instead, we're leveraging a set, and we're using that functionality as a filter. Let's go back to our Start Here tab. We'll choose the Save button to save our workbook this far. And up next, we're going to be doing a performance review. So don't forget to close all of your workbooks down, reopen this workbook to this page, go to the Help menu, go to Settings and Performance, start your performance recording, load your dashboard, go back to this menu, hit Stop Performance Recording, and do that a few times after closing and opening your workbook, just to get a good range of performance for this section. We're going to do this as well, and in the next lesson of the course, we're going to go through the results. Now we'll be going through our performance impact analysis of our calculation optimization section of the course. Our testing as of the filtering section came in between 18 and 20 seconds. Now that we've done our calculation optimization, let's check out our results of our performance recordings for the calculation section of the course. In workbook performance testing, runtimes for this section were between 14 and 18 seconds, an improvement of between 2 and 6 seconds total. This was a moderate amount of improvement, and it will be interesting to see how much the visuals impact performance improvement in the next section of the course. Some of the calculation improvements that we made in this section included replacing regular expression string calculations, defining aggregation inside of calculations, replacing table calculations with LOD expressions, and reordering logical formula syntax based on frequency. When looking at our event type ranking in their raw aggregated form, we can see that there has been some reorganizing in terms of our top events, with rendering going down some and executing query coming back up, but overall our numbers are going down in aggregate. In the next section of the course, we'll be diving into layout and visual optimization.